just a second.
Yep.
Hello, everyone. Welcome to this edition of SAP's Devtoberfest. We are going live now with Christian Lechner. His topic is Pour Some Serverless on Me, part of our Devtoberfest week 3. How are you doing, Christian?
I'm fine. Looking forward to this talk.
Awesome. Thank you so much for being here. So what we wanted to do was have you introduce yourself, talk about what you do at SAP, and then if you could also talk about your subject matter that's going to guide us through the hour, and we'll try to leave about 10 minutes for Q&A at the end. But I'll stop talking and hand it over to you.
Yeah, that's the plan. Thank you. Yeah, so hello and welcome from my side. My name is Christian Lechner. I'm working in the SAP TNI organization, BTP Core and Runtime, so the thing that was formerly known as SAP Cloud Platform. I'm there as a development architect, and one of my topics is serverless. Now, doing some, let's say, management of expectations, we will talk about serverless, but we will not talk about SAP technologies. So if you look at my shirt, you might already have an idea what technology we will take a look at when we talk about serverless. But now let's start. Let me share my screen. And you should see the slides now with the title. And
yes, we do.
Let's go with the topic of serverless. Pour some serverless on me in the name of cloud native. Now, before I start really with the topic of serverless, I would like to take one step back and talk a bit about cloud native. So what is cloud native all about? And why is it hard to achieve a really cloud native application? So in order to start that, I took the very official definition of cloud native that is available from the Cloud Native Computing Foundation. And well, I highlighted some areas. So let me put on the laser spot. So what is cloud native all about? So cloud native is about building and running scalable applications. Okay, so we build applications and they have to be scalable. And they run somewhere in some modern dynamic environments like public, private, or hybrid cloud. So some cloudiness. Makes sense because it's cloud native. And then those techniques should enable loosely coupled systems, which are resilient, manageable, observable. They have to have a robust automation, be able to be changed in high frequency. These are already quite some qualities that we have to fulfill, right? Now, thinking about what we usually do is we build business applications. So most of us, I guess, get paid for solving business problems with the apps that we build. Taking a look at this definition, it seems like you have to wrap your head around a lot of things that have nothing to do with the business problem, but are due to the fact that you want to build a cloud native app due to technology, scalability, resiliency, observability, loosely coupled system, all cross-cutting concerns, all important, but yeah, quite hard to achieve. Now, the question is there any way to achieve that stuff without breaking your hands and diving too deep into technology? And yeah, question is, due to the title, is serverless maybe the answer? Does that one help in order to achieve a cloud native application? And let's us focus again on, let's say, the business logic. So before we start, first question would be, what is serverless? Is there a definition out there? How can we define that? And then we can deduct if it helps us. Now, what is serverless? There was, funnily, not too long ago, a little tweet out there, what is serverless? Right answers only. And the very first answer was a screenshot from a shirt which basically says I came back from the future and it's serverless. So obviously serverless is a hot topic. And it seems to be the one that we should go to in the future. Now, going back to a more formal definition, there are several out there on Wikipedia, and I found one on the Red Hat site that I think is really good. So what is serverless? Serverless is a cloud-native development model. So it's all about developing cloud-native applications. But this model has one big goal. It should allow the developers to build and run applications without having managed servers. So all the hard stuff that you have to do is done by somebody else. What is important, and it's always heavily discussed when the term serverless is mentioned, servers are still in place. So there are servers. There is no black magic that is running the apps. But the servers are completely abstracted away. So all the hard stuff that also comes into play when it comes to resiliency, when it comes to scaling, is done by the cloud provider. They do the provisioning, they do the maintaining, they do the scaling of the server infrastructure. So the aspect of building scalable apps is done by somebody else. You do not have to care about that. Now, what's also great about serverless apps, and that's a quality of serverless, is that those little guys respond to the demand automatically, scale up, and they also scale down, depending on the demand. And this to an extent that they also scale down to 0. So if your app is not pushed by anything, if no event is sent to your app, then the app will scale down to 0. And then a second quality of serverless kicks in. And that's that usually serverless is metered on demand by an event-driven execution model. So this basically means if you have a lot of demands, if you have a lot of events firing onto your serverless app, well, it will scale out and you will pay for that on a very granular level, usually CPU and memory measured in microseconds. And if there is no demand, it scales down to 0 and you do not pay anything. That's great. That also opens up the space for experimenting because you will not have to spin up a Kubernetes cluster and pay hundreds of euros for something that might never be used. Now, there are two flavors of serverless that you can think about. One is really the backing services that have those qualities, so they scale and you only pay for what you use, like databases, like event buses. They are super boring because they just work. So we will not take a look at them within this session. And there is the second part of serverless apps, which is where you put your code in. That's usually functions as a service that are one building block of serverless apps. And this is where we will take a look into. Now, before we start, one important remark that I want to stress. Funny tweet came out when Facebook went down. Facebook went fully serverless. They threw all the servers out of the window and nothing goes. Well, I have to stress it again. Serverless is with servers. There are virtual machines. There are micro VMs out there running, but you do not care about them. You as a developer are not responsible for that. You can focus on different things. That's important. Now the question is, if I now want to start with this serverless development, if I want to make my feet wet with functions as a service, how can I start? How does the development feel like? So how do I develop that? Now, there are a lot of offerings out there when it comes to functions as a service. You have AWS Lambda, you have completely open source thingies like OpenFaaS. Now, when I choose something for trying things out, I have one thing that I really think is important. The FaaS offering that I want to try out should be as open as possible. That means I want to do my experimentation with this stuff locally. I do not want to subscribe to any cloud provider in order to try that out. I want to try that out locally. I want to have the freedom of choice with respect to the operating system that I have, be it Linux, be it macOS, be it Windows. I want to have the freedom of choice of the tooling that I want to use. I do not want to be coupled to any editor. I want to have a CLI usually, and I want to have a lot of programming languages that are supported. And with that in mind, we will now take a look at one specific instantiation of functions as a service, and that's Azure Functions. And that's this little lightning here is the symbol for Azure Functions. Now we will take a look at those Azure Functions and how to implement them completely locally, and how they feel like, what you can do with them, and yeah, how to get things started there. Now, let's go to the code. Let's remove the slides, and let's take a look at what you have to do in order to get Azure Functions working on your desktop, on your machine. There is basically just one thing that you have to install on your machine, and that's the Azure Functions core tools. That's basically the package that gives you the runtime in order to create, develop, test, run your Azure Functions. It's available for Windows, for Mac, for Linux. If you want to start, just a remark, as of now, when we record this video, this session, use version 3. That's a stable one. Version 4 is not yet stable. Now, as I'm a big fan of Visual Studio Code as an editor, I will use Visual Studio Code throughout that session. And in order to make my life even more easy, I will use Azure Functions extension that is available for Visual Studio Code. Now, if you use a different editor, everything will work as I will show you during this session. You can use the CLI that comes along with the Azure Function core tools. And you can use any editor that you want in order then to do your coding. Having said that, looking at the code in a moment, the concepts that I will show will be applicable to each and every function implementation. The naming might be a bit different depending if you're using AWS or Google or whatsoever, but the concepts are always the same. So even if you will not use Azure Functions in the future, the concepts are important to understand, and they are perfectly demoed by Azure Functions. Now, let's start. So let's check. I have my my function core tools installed. As you can see here, we have some beautiful ASCII art, and I have here my functions installed. So I have my runtime, my core tools, everything is in place. And I have an empty directory where I have opened up Visual Studio Code. Now, what do we do first? Let's say we want to develop a little function that exposes an API endpoint. So we can call that API endpoint, give in some parameter, and then this API endpoint should return some kind of response. What do we have to do in order to make that reality? Now, as I said, I will use this extension that I have opened up here in order to create a function. First of all, I have to say, where do I want to store that thing? And I want to store that here locally on my machine. Then I have to say, which language do I want to write my function in? Do I want to write it in TypeScript, JavaScript, C#, Python, Java, PowerShell? Or do I want to use a language that's not officially supported, like Go or Rust? Then I have to go down a bit different path, but I can do that. Now I will go for TypeScript. And then I have to select a template. So there are some predefined scaffolding within the function CLI as well as within the extension that will give you some quick start. Now, as I said, we want to have an HTTP endpoint. So basically, HTTP triggered function would be the right choice. So we take that one. We give it a name, call it HTTP trigger Devtoberfest. And we have to give in some authorization level. So how can it be called? That's nothing that's of big importance for now. Now, taking a look at what happened. The extension created several files. Most of them are due to the fact that I've chosen TypeScript, and basically as a runtime the node, which creates me this package.json. I have my configuration for TypeScript and so on. I have my gitignore file in there. So everything, nothing really surprising there. In addition, I have this little folder here that contains my function code. And taking a look at that, I have two files, and that's already a very decent pattern when you think about cloud native development. I have here a separation of the configuration, which is the function.json file, which contains the configuration of my function. And I have this index.ts file, which contains the code of my function. Let's start with the configuration. The configuration of a function always has some kind of binding within it. So what the binding basically says is what triggers this function. So what kicks off the execution of the function? What is the output of the function? And this is exactly what we see here. So we have here this type, which is an HTTP trigger. So the function runtime knows whenever it instantiates this function, hey, this function has to expose some endpoint. And whenever a request hits this endpoint, I have to trigger it. Of course, the direction is in. And the parameters that come along with the HTTP request, so be it query parameters or be it a body of an HTTP request, are addressable within my function, and I have to give that a name in order to make the function runtime aware to which parameter to assign that, and that's request. I also can define now, due to the nature of an HTTP trigger, which methods I want to support. So which HTTP verbs should be supported, and for the sake of this demo, I just want to support get. Now I want to do an additional configuration. I want to add a route for this function, and I call that Devtoberfest. Now on the other side, I want to have something that is handed out from the function, which is an output binding. You can see that here from the direction. And as I said before, I want to return a response. So I have an HTTP output, a response object with the name response. That's how I will address it. Now, with that, we can switch to the code. And this is, well, quite basic. I will do a short npm install in order to get rid of this little red curlies here, in order to have all the dependencies in there. Now, the function itself is, well, quite basic. We have, if you are familiar with JavaScript or TypeScript, we have an asynchronous function. We have two parameters that are handed in here, one generic context of a durable function, of an Azure function, pardon me, and a request object, which represents the HTTP request. And what we do now is we assign we will just support query parameters here. So when there is a query parameter and this is filled with some value, we say hello Devtoberfest, participant, and we have some name that we put in. And if the name is not supplied, we give some unpersonalized message telling the caller, hey, please pass in a name. And as a result, we just fill the result parameter in the function context with this response message. That's all we have to do. So as you can see here, we have here this request, which is this little guy here. And we have here the result, which is this little friend. That's all we have to do. We do not have to care about how everything is wired up, how the HTTP body and query parameter are matched to the parameters, how everything works together, how the response message is returned. We do not care about that. We just focus on the response message, how that's built, and how what we want to return. Nothing more, nothing less. That's it. So with that, let's start the function. And what I will do is execute a script that's defined within the files that have been scaffolded, which will be building our TypeScript function, and will then, as you can see here, call the function CLI and then instantiate our function. And as you can see here, we have some decent log output. So we see, hey, there is a function. It's exposing a get endpoint, and we can now call that endpoint. Now, in order to do so, I will create an additional file. Which is an add-on to or an extension of Visual Studio Code, which allows me to create HTTP requests. And if I send that one, I get back the message that is non-personalized because I forgot to add a query parameter. So let's go with my name and let's see. Okay, now the other message is returned. And as you can see here on the terminal, you see we have some decent output here with respect to some basic observability, I would say. So the function runtime already exposes all the information, what got executed, mixed up with the console logs that we have issued. Now, that's already quite nice, right? Not too much effort in order to build an HTTP endpoint that is served. Now, when we think about, well, our, let's say, daily work, we usually also interact with some data stores, right? Now, the question is there any decent way, perhaps with this binding mechanism, in order to work with data stores? Now, yes, there is. We can also use this binding in order to interact with data stores, so reading data from a blob store, for example, or writing data to a blob store, making use of binding. So we do not have to wrap our head around any SDK logic, but we can use this generic binding mechanism. Now, in order to demo that, I will start up a little emulator that's called Azure Write. That's also open source, available for each and every operating system. And what this thing does is, it will start up, as you can see here on the right-hand side, an emulator of storage that is usually living within Azure. So we have a blob store, a queue, and a table storage that can be filled and can be addressed. And what we will do now is we will put some files in there. Because we now want to have a function that reads files out of that storage. And I have here two JSON files containing Marvel characters. So if you take a look at that one, little JSON of one Marvel character. And we will now put that into the storage. We can do so by another tool, a lot of tools that I show, right? Which is the Azure Storage Explorer, which is kind of a graphic user interface in order to interact with storage, be it emulated or be it in Azure. And here we have this blob containers. And now I have to take a quick look at my cheat sheet in order not to miss up things. So I will now create a little container. That's called Marvel characters. And what I will do is I will upload these two JSON files. This takes a second usually, and it's getting transferred. Yeah, here we go. Here they are. They are in place now, locally available. Now, what do we have to do? I want now an HTTP function that reads out the data from the storage and returns that to the caller depending on the ID that I hand in. So we have here a Marvel character -1. 1 is the ID, 2 is the ID of the other one. So let's see if we can fetch that stuff. In order to do so, I will now adopt the route. So what I will do is I will now say, okay, I want to expose an endpoint at the Devtoberfest Marvel endpoint, and I want to have a parameter in there which is called ID, which is non-optional. And now I want to add this binding magic. And what I want to have is I want to have a blob binding, and I want to have that in the direction in, because I want to read that blob thingy whenever I hit that endpoint. I, of course, also need a name for that. Let's call that config or whatever you want to call it. That's just for the addressing within the code. And then I, of course, need to tell the binding where to find the files, right? Where is the path to the files? And again, short look into cheat sheet so that I do not make any typos. We have no time for that. This is where I specify the path. So I have here this blob container that you have seen right here, Marvel characters. And then I specify the file name. So I have Marvel character, I have the .json. And another cool thing is I can directly address this ID that comes in via my route to my path. So the wiring up is also done by the binding. So I do not have to care about that. That's great. Then let's quickly do the code. So let's remove everything that we had before. And let's put in a little code snippet, which is really basic. So what does this code snippet do? It takes a look at the config parameter. So it takes a look, is this config, is this input binding to the blob store? Does this have any value? Is this assigned? If this is the case, I will return the content to my response message. And if not, I will, well, return a message that nothing was found. And then again, as before, I will build up my result. So the thing that is returned by the HTTP request to the caller with the corresponding status code, with the corresponding response header, and the response message. Now, as you see here, from a coding perspective, what I do is I just check if the binding has found something. I say, okay, if there is something, I fill the response message and I put that response message into the result object. Nothing more, nothing less. I do not care about how this blob store is addressed, how the select is done, where I have to look. I just do this little steps that kind of are comparable to purely focusing on business logic. Now there is one more thing that I have to do in order to make the system aware that I'm using a local storage, and that's also built in within Azure Functions. And that's this little thing here. So I just tell the environment, hey, when you look for a storage, when you try to evaluate this blob binding, then use a local development storage. And this development storage that I emulate exposes some standard ports, so everything is working nice and neatly, hopefully. So let's do the reality check. At least we get this new endpoint exposed. So we can now take that one, take our request.http file, and try to make a request there. Now we said we have an ID equals 1, which should give a result. So let's see. I will remove that one. And yep, that is Scarlet Witch. Now, who is the second character that we have stored? Oh, my second favorite character of the Marvel universe, Star-Lord. And yeah, let's see what happens if we enter a non-valid value. Not found. Yeah, that's what we implemented. Now let's stretch it a bit. What happens if we hit a route that is not allowed? Again, the function runtime takes care about that. It's a 404 not found because that's not defined. We do not expose that. So again, we just have to focus on what to do, but not on how to do things. And that's, I think, really, really great and helps a lot when doing coding. Now let's switch gears and let's go the other way around. So let's say I have a post request and I want to store something in my blob storage. I want to call that one stage. And now I have to also define a different route. I want to have this data posted within an HTTP body. So I do not need any ID in there. Now I do not want to store that directly into my Marvel directory in my storage there in this container. I want to have some staging environment where I put that in. And this should also be reflected within my path. So again, I define where to store the data. So this time the binding will go out, so it will write to the blob store. It will go to a container that is called staging. If it's not there, it will create it. We will see that. And then I will give in some naming convention. I will take the ID and the nickname. Now, where the hell do those things come from? Here I anticipate that the payload, the body of my post request, has a specific structure. And I take those parameters automatically via the binding magic and put them into the path. Now, with respect to the code, I will shortly copy that over. No real rocket science in there. So let's remove that. Let's put that in. So now let's reflect. We get a request. The request has something within the body. So if we have some data in the body and I do not any validations, which of course you would do in a serious setup, and then I simply throw that body into the parameter that I defined for the output binding, which is called stage. And then I add some messages for the response. And if there is no body, well, I hand back a 400. And that's it. That's all I have to do. That's basically the logic I have to implement in order to store the requested stuff into my blob storage. Now let's see if this works. So we will do another npm run start. Now we need a little bit of a different request. As you can see here, on the lower part, the endpoint was again adjusted as we have configured it. And now, in contrast to the previous executions, I now just have a post. So I have no get endpoint there. Now let's do a short copy paste of the post request. Now we will put in a different Marvel character, the Hulk. We will use a little feature that comes along with this extension, which creates a GUID behind the scenes, so nothing to worry about there. And then we will fire that one. So at least the response is saying that there was something created. Let's check if this is the reality. So let's refresh our blob container. And indeed, we have a staging created, and we have this Marvel character, this new one. Let's open that one. Let's do a little bit of formatting. And yep, exactly the thing that we have done there. So we have now really stored the data with one line of code that we have fetched from the HTTP request down into our blob storage. That's cool from my perspective. Now, shortly going back to the slides. I will shortly shut down things here. Close that one. And let's shortly go back to the slides and ask ourselves a question. We have now done some serverless magic. We have some functions implemented. API point reading, writing to a storage. That's not bad. But when we think about, especially SAP, we always have business processes that we have to think about, right? We always have some kind of workflows, some steps that are executed in sequence, in parallel. We have some sync points and so on and so forth. Can we do that with serverless? So basically, from a pseudo code perspective, we have something like that. We call, let me shortly go to the laser pointer. We call some function which gets a result, and this result is the input for the second step of our business process, and then we get again a result, and we use that for the third execution, and then we return a final result. And these steps have to happen in sequence. Now, is this easily possible with a serverless setup? Now let's take a look at some qualities of serverless or some restrictions of serverless. Due to the fact that the functions are scaled automatically by the platform and also scaled down to 0, all the functions are stateless. Functions must be stateless. You cannot implement any state in there. If you rely on a state within functions, you have lost because this will not be preserved. So this is already something you have to wrap your head around because this stepwise execution needs a state, right? We have to have something like that. And then there are two more paradigms because now you can say, okay, if I have all these steps implemented in function, well, one function can call the other function, and then this function can call the next function, and then the chain returns, right? Well, you can do that, but then you kind of mess up the serverless approach. Because within this call stack, the outermost function has to wait until the innermost function from this chain returns its result. So it cannot be scaled down to 0. So you will pay for execution time that indeed is not used. Usually you would expect that only the execution of each single function is charged to you. So you can do that, but you should not do that. And then there is one thing that you probably also heard from in the microservice session that was earlier this week, which is true for microservices and is even more true for functions. Functions should do only one thing and should do this one thing well. So what is an anti-pattern is to create so-called fat functions. So functions that do a lot of things. You basically can put everything within one function, of course, but then you have a very fat function that is very hard to maintain, does different things, so not the best pattern here. Now, let's see if we can, with this binding stuff that we just learned, somehow implement such a workflow-like behavior. Now, what do we have to do? Let's say we have a function, and the function stores a result within a storage, as we have seen within the pseudocode 2 slides before. When such a parameter is stored, an event is raised from the storage, and the event can, of course, trigger a second function. Now, this function does its thing, stores the result into another table, into another storage, another event queue maybe, and scales down to 0. And this event then triggers a third function. Now, this would be a perfect solution for the requirement that we had before. Nevertheless, now, there are some downsides. You really have to wrap your head around how to wire things together. You also have a very severe downside when it comes to, let's say, maintainability. Because those functions are just connected via bindings very loosely, which is good, but you do not see the business process when you take a look at the code. It doesn't get obvious. It's somewhere inherently put into the definition and so on, but you will not see it at a first glance. In addition, that was a simple sequence of steps. Think about a parallel execution where you have these three functions that needs to be executed in parallel. And only if all three functions have returned and came to a result, then the next step in the workflow should be executed. How do you do that? That gets more and more complicated. And again, we move more and more away from focusing on the business problem to focusing on how the heck do I solve those technical problems? What issues do I have to overcome? And of course, you also have then have to have a very decent monitoring, because things will go wrong and you have to care about that. Now, of course, there are solutions options for that. There are several frameworks that support you there. And as we have started with Azure Functions, let's continue with them and take a look at the so-called Azure Durable Functions. Here, I would like to introduce you to three new friends within the Azure universe. First one is the client function. The client function is a function that gives you or is the door into your workflow. So you will call the client function from your application and tell this client function, hey, I need a workflow that needs to be executed. Go ahead and tell the workflow to start. That's one ingredient. Then the second ingredient is the orchestrator. That's kind of the main part of modeling workflows within code. So we are really talking about imperative modeling of workflows, not a declarative modeling of workflows when you talk about durable functions. This orchestrator does what its name implies. It orchestrates the execution of other functions. There is no business logic in the strictest sense within this new function type. It's just orchestrating other functions. And last but not least, we have the so-called activity function, which executes the business logic. So here you can now really follow these paradigms that I mentioned before by designing functions that do one thing and do that one thing well via the activity function, and the orchestrator, which does just the orchestration of the activities, execute them in sequence, in parallel, have sync points, trigger off really complex workflows, no matter what. That can be done within there. That's all you have to care about. Now, what's happening behind the scenes? There is no black magic that somehow brings those things together and everything works. No, behind the scenes, there is event sourcing. That's used in order to model the execution and to make sure that this statefulness is brought to the stateless functions. But you don't have to care about that. Nevertheless, let's take a short look what is taken away from you by the framework. We have our three new friends, the client, the orchestrator, and the activity, and we have some storage, some queues. And when you call now the client in order to execute an orchestration, this will put in a message into queue. And then the orchestrator that was scaled down to 0 then will wake up, will see, hey, I have something to do. Let's look at what I have coded within my function body. What activities do I have to execute? And now I will schedule the tasks for those activities, starting with activity number 1, putting a message into a queue. Then scaling down to 0 and letting the activity do its thing. When the activity is finished, it will return the result, and the orchestrator will again wake up and will check, hey, do I have something more on my list to do? And will invoke the next activity. Nevertheless, you do not have to care about all that wiring, all that storage of the events, of the replay logic, of what happens when an activity could not finish successfully. That's all done or taken over by the framework. So in order to show you that, let's do some more code with some more functions. And this time, in order not to annoy you with me typing, I have already prepared something from the setup side. You see here, again, some very well-known friends now. We have our package.json, we have this request file, we have this config.json, everything's fine. And we have now 3 folders that obviously seem to be some functions. So at least they have the same structure as we have seen before. Let's start with this starter function. How is that configured? Let's move things a bit around. So what do we have here? As we are experts now in binding, we see at once, okay, that's an HTTP trigger function, which is listening on that route and supports those 2 methods. And it obviously returns some HTTP response. And here we have now some new ingredient, which is a starter. Okay, that's an orchestration client. So what does this binding say? This binding says to the function runtime, hey, whenever you invoke this function, that's an orchestration client. So this little function is allowed to call orchestrators, and only functions that are bind to this type are allowed to do so. That's it. Within the code, there's also no real magic in there. Basically, what we have is some infrastructural code that simply kicks off an orchestration. So we create a new orchestration client and start a new instance on that client. That's it. The orchestration is then executed asynchronously. So what we will do, and what you will see later, a status page is handed back to the caller that he can interact with in order to get the current status of the process. That's it. So that's your entry door into the orchestration. Now the orchestration per se is implemented in the orchestrator. Let's take a look how that's configured. And again, the concept of binding kicks in defining what type of function is that? And that's an orchestration trigger. So that's the one thing that triggers an orchestration. Whenever the function runtime sees such a function, it knows, okay, that one is an orchestration trigger. I know what I have to do with that one with respect to the event sourcing. I know what parameters this little thingy needs. And I will do the stuff for you. You told me what I need to know. Then we have the code. And within the orchestrator, again, we just implement the logic in order to define our workflow as code. And basically what we have here is we will have a little array that we will fill up by sequential calls of an activity function that will then have some strings in there. And we basically just call an activity, you know, the third ingredient within the durable functions SU. And we called it by a name. So hello dev advocate. And we say, first we want to say hello to Josh, who's hosting the session. Then we want to say hello to DJ, our terminal magician. And then we want to say hello to Marius, who is the UI5 specialist. And that's it. No business logic in there. So whatever happens within the activity happens within the activity. We just say, I want to execute those steps in this sequence. So where is the poor little function that has to do the work? That's the hello dev advocate function, as you can see here. That's the one. And this one, again, comes with a definition, with a saying, hey, I'm an activity trigger. So I can be called by an orchestrator, by nobody else, just by an orchestrator. And within the function, we have now some very sophisticated business logic. So we return a string that just concatenates the parameter that we hand in and gives back a string that will then be pushed on the array that we had back. And that's it. That's all the magic that we have to implement. So as you can see, at no point I have implemented some fancy logic around event sourcing or something like that. I have no information how those things get wired up. Now let's start things. And again, I will start Azure as a storage emulator, because we need that in order to store the state. As I said, there is no black magic. It's event sourcing. And then we can start the function. This can now take a bit because the infrastructure has to be set up within the table store. But that was quite fast. So what we will do now, or what we will see now, is we have 3 functions. And we can now send a request to the orchestrator, kicking off the orchestration. And as you can see, quite some things happen here. And we get back this status page that we can then interact with. So I will now take here this status URI and do a query. And let's see. Yeah, that's what we expected, right? We get an array which has 3 entries. We have first a greeting to Josh, then a greeting to DJ, and last but not least, a greeting to Marius. So things worked out as expected. With really a minimum amount of code, we have now implemented a completely serverless workflow sequence of steps that we can use. Now, the question is, and let me spend one more minute on that, what happened behind the scenes? So what heavy lifting was taken away from you? And we can see that from the storage, because that was used in order to facilitate the event sourcing. So what we have here now are 2 tables, where we have one table which basically represents the execution of our orchestration with a defined GUID, which is the partition key, which you also find here as an instance ID. And then we have the event sourcing. That is all happening behind the scenes for you. And you do not have to do anything about that. So here you see clearly the single steps on the event chain that have been executed. We have an execution of an orchestration. The orchestration started, scheduled the task, and then went down to sleep. The task was executed, went down to sleep, and the orchestrator woke up again, took a look. Okay, I have another task to execute, and got down to sleep again until everything was finished and the execution was completed with the result that we have expected. So really, things are made a lot easier with this serverless paradigm. You can really quite easily implement your cloud native applications and still focus on the business logic without having to wrap your head around something like event sourcing. I mean, it's interesting, but the business problems are the things that we should solve. So wrapping up, what did we achieve with functions as a service, specifically with Azure Functions that I have showcased here? Well, within 40 minutes, something like that, I think, we have created a simple API endpoint that could react to requests and return the response. We have read data from a blob store without using any SDK with 1 line of code. We did the same with writing data to a blob store without the SDK dance, just doing it with 1 line of code. And in addition, and that's really something that's super cool, we created a sequential execution of serverless steps. So we really followed the serverless qualities and nevertheless brought state to the stateless functions without too much code. And the coolest thing is we did all that stuff locally. Now you might say, yeah, okay, cool, nice. Azure Functions, if I deal with Microsoft, if I deal with Azure, okay, that's probably the one-stop shop. But maybe I'm not a big fan of that. I want to have open source stuff. I want to use open source stuff. Now, all that I have shown you is open source. Azure Functions are open source since day one. They are under MIT license. So you can use them and deploy them even to a Kubernetes cluster if you would want to. So that's also possible. And from my perspective, another aspect why I personally really like Azure Functions as an instantiation of functions as a service. And with that, I thank you very much for having me. And I think we have some time for questions.
Yeah,
nevertheless,
perfect.
if you want to reach out to me, here are my contact data. Twitter is the preferred one.
Nice. So Christian, we had a couple questions come in. Really good presentation. I took a lot of notes. First question was early on in the first half, and it was from Fedor, and he said, what's the add-on to send request? So if you can put your brain around that time period in the first 15, 20 minutes.
The add-on, that's the, I have to shortly look. But I will find it out in a second.
No problem.
I always forget that.
I thought about interrupting you, but I was afraid of ruining the flow. So I wanted to make sure we came to it at the end.
Yeah. It's called REST client for VS Code.
REST client for VS Code. Perfect.
I can shortly share my screen again.
Sure.
So this is the one.
Awesome. Thank you so much for doing that. And you kind of wrapped up the second question that I saw in chat, which came in at the end. If Cyrillic translator is working, it's from Alexander. And he's asking, is this framework something wired to Azure, or is this a generic thing?
Yeah, so that's a cool thing. So I have to be honest. It's open source. It's under MIT license. Of course, the governance lies at Microsoft. No fuss about that, but that's kind of how it is. They contribute most of the stuff. Now, for example, the HTTP trigger, or let's say a Kafka trigger or something like that. That's something that you can deploy as of now into like any Kubernetes cluster. With respect to, of course, bindings that are bindings to the to Azure specific services. Well, no surprise, you need Azure specific services in order to do the binding. That's something that that you have to keep in mind. When it comes to the durable functions, as you have seen, I have emulated the storage. So currently, Azure Functions, durable functions are wired up with Azure services. So you have to have some connection to the Azure services. However, there is a workaround. Maybe you know Dapper, which is, I don't know if you came across that in the last session around microservices. Shame on me, I didn't watch it.
No problem.
Dapper is another project, another open source project, which gives you some building blocks in order, for example, to store state independent of the state management. So you can have a Redis cache in order to do the state management or to do the pub/sub. And Azure Functions have a binding to Dapper. So you can kind of build up at least a bit of the stateful things with this binding. But really the workflow part, the super hard part from my perspective, that's currently bound to Azure services.
Okay. I wrote down a couple of questions that we have just a few minutes left. I don't want to hold you too long, but I think it's important you expand upon where you said focus on what to do, not how to do it.
Mm-hmm.
Can you expand on that a little bit? Like why serverless is so important versus maybe if you were doing this in a full stack traditional build or a non-cloud native environment?
So if you think about, if you want to build microservices and if you really want to build them up, you have to wrap your head around, for example, the scalability topic. So you have to think about how do I do this scaling with my stateless microservice? What mechanisms do I make use of? How do I do that? how do I scale back once there is no more load on my microservice, because I don't want to burn money by scaling out, let's say, pods or within Cloud Foundry, my deployments of my apps without any need. And this is something where within serverless, you don't have to wrap your head around that. You just implement the function, you deploy to Azure, and the scaling is done for you. And this is, from my perspective, a very important ingredient. Also, I like technology. I like to deal with technology. I like to play around with technology, and that's, from my perspective, something that is the complete anti-pattern if you want to solve business problems. You fall a lot in love with how you do things, how you wire up things, what tool, what new framework is out there, what can I use, and get rid of the business problem to some extent, but that's not the way how it should be.
No, you remind me of a speech from Steve Jobs back, I think it was 97, and he was talking about making a printer. And he had said, I have this great printer, the best technology in the world, but if nobody's going to use it, what good is it? So it's the best printer. They built a printer instead of what is the person needing to do. So look at the functions that you're going to do, no pun intended. Yep. So here's a fun question real quick to wrap up on. I was paying attention and I heard you say that Star-Lord was your second favorite character. Did I miss your first one? Was it?
The first one is, of course, Deadpool.
Really?
Yeah, absolutely.
We could go through a whole religious battle on which movie is better too. Because I've elevated Ant-Man way up. Just
okay.
As a big Paul Rudd fan, and I look at what he's accomplished anyway.
No, that's Deadpool number one.
Okay, I like Deadpool. He's in my top 3.
Okay, cool.
Good. All right. I thank you so much. Any other final thoughts or anything you want to talk about you're doing at SAP before we wrap up?
No, nothing specific. So if you're interested, if you have any questions that come up in your mind afterwards, just ping me on Twitter. That's an option. And what may be also interesting for you, let's make some shameless advertisement. There is a great open source project out there that's called Azure Functions University, which is done by Microsoft MVP Mark Duike. And I'm also contributing to that one with respect to TypeScript lessons. And there you find a lot of lessons all around Azure Functions. And they are all recorded on YouTube, split it by the languages that are supported. So of course, .NET Core within the Microsoft ecosystem, no surprise that that's number one. We have TypeScript, we have PowerShell. And as you can see here, you can dive in the prerequisites. For example, here we also have the REST client referenced. And we have all those lessons, which are really lessons. So you can walk through them. Let's take this blob binding. You really walk through them. You have a lot of sections and you have the recording on YouTube. So you can either walk through them by text. You can watch the YouTube wherever you want to jump in and so on. So if you want to make your hands dirty with that, highly recommended content.
Nice. All right. Our audience appreciates that so much. Thank you for being part of Devtoberfest. We are halfway through, as I mentioned. We also have launched a lot of tutorials, scavenger hunt, a lot of points to be earned in the contest. And we are going to have a Fun Friday event tomorrow and then lead into next week, which is Security Week. So again, thank you so much. I have posted a tutorial for your speaker event with a question to answer to earn some points. So thank you for that. And I will end the live stream now. Thanks, everybody, and have a great day.
Cool. Have a nice Devtoberfest. Bye.